This conference will now be recorded.
If you're not able to see my screen, just on the right side we have three dots on the right side. If you click on it,
Mm-hmm.
we have an option called toggle full screen. You can use that one.
Yes.
If you can improve, you can improve it a little bit. Yeah.
Oh yes, thank you. Thanks for that.
Yeah. So the course content will be we'll be teaching you Amazon Web Services, Linux operating system, introduction to DevOps, Git and GitHub, Jenkins, SonarCube, JFrog, Ansible, Terraform, Docker, Kubernetes, and Prometheus, Grafana. So these are all the tools we cover in this 60 sessions course. We have around 60 session course. Initially, the course will be around 1 hour per day, but now
Mm-hmm.
after some time, I will increase it to 1.5 hour. Once you are able to understanding, once you are in sync, then
Yes.
now I will increase the time from 1 hour to one and
Yeah.
a half hour. So mostly sessions will be around 60 sessions.
Mm-hmm.
That is about the course.
Yeah.
And
So just a small thing, Madan. We are working as an ID support analyst. Seriously, we have no we did not think about this DevOps role and all. It's just been 1 week for us. Like we just thought and just we did some research on DevOps and all. Like we just want to move into DevOps. It's like learning from scratch. We don't have any idea about what these tools and all. Like it's
Yes.
correct,
Yes.
we are
Yes.
zero.
correct.
Yeah.
Got it.
And we
Yeah.
have some idea because during our bachelor's in computer science, around that, but we don't have any practical knowledge, and it's been a while to be honest. And
Yeah.
we are about to enter into this. It's a whole new thing, so we are starting from
Yeah.
scratch, as Tarun said. So
Yes,
this is our
perfect.
background.
Got it. Actually,
So,
to be
Madan,
honest with you, yes, please. Yes.
yeah. So, are we involved in any project like live project so that if in case of any interview, so we can prove ourselves like we have done this, and it would be like very much helpful for us.
So, Tarun, actually, in this complete course, I will use whatever I'm doing in real time. The same, my
Mhm.
experience, whatever I am doing, the same thing I will do here actually. So, whatever you're learning here, the, you will be doing the same thing in real time as well. It won't be different actually. It won't be
Yeah.
different. And moreover, to explain you that, I also want to inform you that some of my students, maybe
Yeah.
not in call in as a support call center, in the call center, they are not working call center, but some of my students are also from UK and US. They are working the what do you call supermarket. So they also whenever they get time, they take online training from me actually. So students are like that also, so who are in marketing, they also learning from there actually. So don't worry about your backgrounds, because everything from
Yeah.
scratch I'm going to teach. Everything from
Okay.
scratch, because in the screen itself, in the beginning itself, in the agenda itself, I will tell you like no what are the prerequisites to join AWS with DevOps, and who can join this course info, and introduction to course, who instructions to attend this course. So if you go to the prerequisites here, no prerequisites to learn AWS with DevOps actually. So the only your time is required actually. So you have to spend
Yep.
good amount of time after session is completed. Otherwise, even
Yep.
you are experienced, non-experienced, it makes no difference actually. So
Hmm.
end of the day, only your efforts and your dedication is makes you perfect actually, even though you don't have experience. See,
It's one.
actually, IT employees like no developers, testers, support team, they can do this course. Non-IT, even I teach non-IT people also. So
Mm-hmm.
I even teach non-IT people, because after some time, initially they will feel some problem, but later on, slowly, they will get familiar with the complete course. So they don't feel that they are from non-IT, because if they practice it, definitely they will get that feeling. If they are not practicing, then only the problem. Even it's a developer also, if you don't practice, then no use. Even a non-IT person, if he practices, then no, you will gain a lot of experience while practicing,
Yeah.
because he at least get a chance to ask questions in the class.
Hmm. Yeah, as you said, we never thought of DevOps side and all. We like Sandeep, he just had an idea about like Intune administrator. He just thought of going that side, and me, I just done with my masters, and it's just been 2 or 2.5 months for me. I've joined in the
Mhm,
company and working as IT
mhm,
support. Like, yeah, we never thought of this as like AWS DevOps and all. Yeah, so
Thing is, even so, if you want to come to IT industry, either you have to choose either a development area, or you will have to go to some like data science or machine learning kind of, or else some testing support team kind of, or else we have a lot of options actually. But out of all these, DevOps will be better because even I worked as a developer, and every day, even though I have a lot of experience in development, even then, whenever I get a new task, I always used to feel pressured because the task
mhm.
again, even though my experience may not work there, because the task is different. Every time the task is different. Sometimes the
Hmm.
task may be easy, but every time, whenever I get a task, then I have to spend some good amount of time how to uh, work out how to bring a solution for that. So for that I used to Google, and after some time I used to get some solution. Even though I have experience, still I have to search the Google. So
Yes, yes.
yeah,
it's not that even though I have experience 12 years, I can't do the complete the task just like that. So in that, as a developer, you will have that issues, but as a DevOps engineer,
yes,
uh, because there is very less stress, and moreover, the tasks you do are always, most of the time, will be same. You won't find them
yes,
any different. You won't
yes,
feel any different, and you don't require anything, need to do any different thing. But if you are
yeah,
interested, you can learn some other tools on your own, right? And you can tell your manager that I found some tool, this is more better than this. That way
oh,
you get such that much time actually as a DevOps
yes,
engineer.
yes,
But whereas
yes.
developer as a
Like,
developer, yeah, as a developer, we used to follow agile methodology, and in agile methodology we used to have only 10 days working days, and these 10 days we have to complete the task. If you don't finish it, and then again it will be spill over to next sprint, so a lot of issues will be there over there. But now, as a DevOps engineer, they never worry about it. They simply has to, if they know the tools, then they efficiently use the tools, and they will simply do their regular job. Then
yes, yes,
nothing they
yes,
have to they no need to think anything differently.
Thanks
yes,
for that. And how is the job market, Madan, for this DevOps
job
engineers?
job market, actually it's like a stock market. See, stock market, you see, always it goes up, right? Always it goes up,
Hmm.
but in between lot of falls will be there, lots of gap ups will be there.
Hmm.
Same thing with the IT also. Because if market is not good, it doesn't mean that all the companies doesn't have any work, right? Market is not
Yes, yes.
good means doesn't mean that, right? Definitely, most of the companies will have some work, they got some projects from somebody, from some clients, right? So markets always is there. Only thing is that we have to do not think about this market, and simply upload your resume, and concentration on the ready for the, if at all get a interview, then ready for the interview, and crack, do your best in the interview. That is the only target we should have when the market is good
Hmm.
or bad. Good or bad,
Okay.
yeah,
maybe when market is good, maybe every day you will get 4 to 5 calls or 8 calls. When market is not good, maybe you are getting two to three calls. But
Yes,
we
yes,
want only one interview to be get succeeded, right? That's all.
yes,
yes.
yes.
So, Quickie Madan, like, what do you suggest, like, on the based on the job market and all, like AWS DevOps is better or Azure DevOps? Just
Yeah,
Azure or
if you
AWS, what do you say?
if you go with AWS DevOps, then no, you can learn on your own. Azure and GCP, you can learn on your own, no problem at all. You master on
Okay,
cloud provider and one DevOps. That's it.
yeah. So
Because we have a lot of
it's
jobs on AWS. Yeah, yeah.
Okay,
yeah,
the
yeah.
job market is more for AWS. That's what I have
Yeah, that's what we
seen.
just first thought of Azure, but like we just found two guys here working as an AWS DevOps. Like we, we did not find any guys working on Azure, so we just thought of AWS first. And if the market is far better, like in couple of years, we just can move. Like we'll have more experience in AWS, so that we just can move into Azure.
obviously, right? In the same company, you will get opportunities to work on Azure as well, because
Yeah.
mostly Azure will be used mostly for .NET applications at the time. If you got a internal project as a DevOps engineer, you got any project on Azure, then you can take it up, no problem.
Yes. Yes.
Hmm. Thank you, Manda. You can go ahead.
So yeah.
Yes, sir. If you have any questions, let me know.
Yeah, Madan, like you know what, the guys in Australia, like the recruiters and the guys who are hiring, they just they just want the guys with more experience or like the more skills. Like we just have no experience in this at all. So hope you can understand the situation. Like with zero experience, we just have to go with the course forward. Yeah.
See, actually, no, I understand your situation. I can clearly
Yeah.
understand the situation. But no, thing is that you see, it's same like going to gym. It simply is going to a gym. When you go to a gym, no, initially we don't have that much physique, right? But regularly, when you
Yeah.
go after 3 to 4 months later on, you yourself see some changes in your body, right?
Yeah.
Definitely, right? But if you're not
Yes.
doing properly, then definitely you won't find any difference there. Though it depends
Yeah.
exactly
So
on you how much you worked on in the gym.
yeah. So Madan, can you help? Can you help us with the resume after the course and all?
Yes, yes, I will provide you templates of resumes. So
Mm-hmm.
we can prepare it using that, basing on how much actually this course helps you. You can easily put on easily 3+ years of experience. You can that much
Okay.
knowledge you will gain after completing this course.
That really sounds good.
So
Thanks for that,
yeah,
Madan. Yep.
accordingly, I have some resume templates, so you can
Mm-hmm.
use them. And also I will provide interview questions as well. So now
Yep.
after completing this course, if you see those questions, then now you will definitely get some confidence that
Yep.
easily you can answer them by seeing the questions.
Yep. Sure. Thank you, Madan.
Yep,
So you can just continue. Thank you for that.
no problem, no problem. So the course name is AWS with DevOps, and I am Madan. And the course duration will be around 2.5 months, or you can take it as 60 sessions. So
Mm-hmm.
it will be Monday to Friday. Initially, it will be 1 hour, and later on, I will increase it to 1.5 hour. And
Mm-hmm.
sometimes on weekends as well. On weekends as well, I will take, but I will inform you prior. And
Yep.
class mode will be both offline and offline. And then every topic, once a topic is completed, I will provide you the documentation accordingly. And also every day recordings will be provided to you. Once class is over, after 1 hour or 2 hours, I will institute will upload you the recordings. So for example,
Yeah.
if you see for example, if you see this morning batch somewhere here, yeah. So this is a batch. So normally the documents will be provided like this, the PDF format. And
Mm-hmm.
sometimes we will have also running notes. So whenever running notes is there, running notes also will be provided. But mostly the cloud will be GUI based. That's the reason running notes will be a little bit less. But when you're working on
Mm-hmm.
DevOps tools, you will have a lot of running notes. And when you go to recordings, apart from documents, we have recordings. Every day recording will be named like session 1, session 2, like that, with the date and the topic name. So today we had a session on Lambda. It's on March 11th. So like that,
Mm-hmm.
all the topic every day topics will be covered. So topics will be
Mm-hmm.
like this. So I told you only high level topics I shown you. But when you get into deep of the topics, so these 13 topics I mentioned you. But internally we will deep dive. We will learn each and every topic, most of the services on the web
Yep.
services. So these services
Yep.
same, if you know these services, then you can easily work on Azure or GCP. The only names are different, but internally the infrastructure is same. So like the
Mm-hmm.
AWS, we have Linux operating system. We will learn. We won't master in Linux, but in real time, how much we required, that much we will learn in Linux operating system. So after that, there I will also teach you shell scripting. But some companies are asking for shell scripting as well. That also I will teach you. And then introduction to DevOps. After that, Git and GitHub. So they are the
Mm-hmm.
DevOps tools which you may be heard of. But now we
Yep.
will deep dive all these topics Everything
Yep.
will be practical oriented. So practical, around 85% it will be practical only. Just 10 to
Oh,
12% only theory part, that too for
yeah.
few days. After that, most of the
Hmm.
time we'll be doing practicals only. And then
Yep.
we have a mediator tool called Jenkins, uh, and uh, and then Sonar Cube is a tool which will check the quality of the code. And we have JFrog, which is a binary repository tool. What is binary code repository? We will learn. I will tell you slowly. But this is a tool we learn. And Ansible, it's a configuration tool. So this using this tool, so we can deploy softwares into multiple servers within minutes. So this is one of the automation tool. Similarly, we have Terraform. Terraform is a tool which will create the infrastructure on the cloud. So this also will learn. And then the most
Hmm.
demanding course in the market is Docker and Kubernetes. Docker and
Yes.
Kubernetes. So this part also I will cover deeply. So
Hmm.
after that we will learn Prometheus, is a monitoring tool, and then Grafana. Grafana is not a monitoring tool, but it's simply a what you call UI tool, which will show you the logs which are created by the Prometheus tool. That logs it will show in the form of charts, and in different formats to show the content of the logs which are generated by the Prometheus. You
Yeah.
can think it as a viewing the data created by the Prometheus in a graphical user interface, in a normal graphical user interface. So that
Yeah.
provision the Grafana will give us,
Hmm.
right?
So,
So
Madan, what are like IS2 or EC2? Do EC2? Do you have any idea about EC2 and all?
it's a
EC2.
very basic topic. It's a very basic topic. So in this demo you will understand more thoroughly about EC2. After this completing this demo, you will understand what
Okay.
exactly EC2 is. Okay, so let's start the
Okay.
demo, and then will understand what is EC2 here. Okay, very simple one.
Yep.
So that is about the backup of recordings. And after completing this course, you can easily put on 3+ years of real-time experience. If you're able to put on 3 years experience with some support, then you can easily add 3+ years. And accordingly, I will provide you the resumes. You can add into your resume. And real-time
Oh,
projects, not exactly the
okay.
data will be changed here. Data will be changed here. Real-time means don't expect the real-time data, but data will be changed. But everything will be real-time only. And resume
Yep.
building support and mock interviews will be provided. Okay, I will provide you interview questions as well, and we will discuss on those interview questions as well once we complete the course.
Yep.
So only thing normal things, so you should have your own laptop, desktop, and you have to attend 1 to 1.5 hour, and daily 2 3 hours practice is required. And also weekly tasks, whenever a task is whenever a task I can possible, I can provide you the ask you to do a task on that current topic. So
Sure. Sure.
that is, yeah, that is about it. And before understanding what is DevOps, we will come back to the screen in a moment. Okay, but before that, let me explain you a few basic things. Why
Yep.
DevOps? What is DevOps? See, some 25 years back, 25 years back, at the time, we do not have these many web applications. We do not have these many e-commerce websites. At that time, mostly we used to have desktop applications.
Mm-hmm.
Used to have desktop applications. So So at the time, the developers used to be follow waterfall methodology. Waterfall methodology. So this comes under software development lifecycle. Of software development life cycle. In this software development life cycle, we have different types of methodologies how a software development can be done. In that, there are different types of methodologies. On In that, one of them is waterfall methodology. But waterfall methodology was worked very well in those time. At 20 25 years back, it worked very well. In waterfall methodology, what happens is that whenever a company gets a project from a client, then the developers normally they will complete the complete project. Only then they will give it for testing, and once the testing is done successfully, then only the project will be given to the client. That means till the project completes, the client will not get anything from the project. He has to wait. If the project takes 6 months, 1 year, 2 years, even then the client has to wait for that much period. So at that time, they used to follow waterfall methodology, but the clients used to wait at the time, because at the time there is not that much competition in the market. Like today we have, that much competition was not there at that time. At that time mostly there are desktop applications. So because of that, clients also never asked the developers to give the project, even though it is partially completed, parts wise, they never asked to give. So they are okay, even the developers takes 2 years or 3 years time, and once they complete it, even that is okay for the clients, because there is no competition at that time. And normally in a software development life cycle, we follow different methodologies, like different steps we follow. Initially, we will gather the requirements. Requirement gathering will be happen, and then requirement, once the requirement is gathering is happened, that means the company employees, the IT company employees will go to the client location, and they will understand what their requirements are. Once they understand the requirements, then they will analyze the requirements, like know whether they can do it or not, whether can be completed in their budget or not, whether it can be completed in 2 years or 3 years or not. Everything they will discuss. If everything is fine, then they will go with designing. They'll go with the designing. Those designing will be done by the architects, senior members of the development team. The architects will design the code, design the project, and then they will give it to developers to code. Developers will code it for a long time, around 6 to 1 year time, depending on the number of requirements they have. And then finally the code will be deployed. Deployment means, what is deployment? Very simple. You download, normally what you do, you download some softwares on your local, on your laptop. You will install them, right? You double click on the downloaded binary file and you install it, right? So that is nothing but, you call it as you have installed something, but in IT industry we call them as deployment. Deployment is what? Simply whatever the code written by the developers, that code has been installed in one of the server. So this deployment can be was done by whom? Done by administrators. So administrators do the deployment. After that, code is deployed, then the company will do the monitoring. The company will provide 6 months to 1 year free monitoring service. Like, because after delivering the product, if anything happens to the product, then the company says that, IT company says that, don't worry, we will give you 6 to 8 months support. After that, we will charge you. That way, initially they will give free support. So that comes under monitoring. So monitoring is again done by whom? Administrators only. So here, one important thing you should understand, in waterfall methodology, the administrators are not that much stressed. They are not that much stressed, because the administrators, when they are working in a company, normally they handle different projects in the company. So every company, every project normally used to take to complete around 6 months to 1 year or so. So different projects, they come at different times. So different times to deploy their project. So administrators will be asked to deploy the project into the servers. So these administrators are at the time were not so stressed. They're able to complete the deployments very easily. But slowly the now market has been changed. Now the market is completely with web applications, completely with e-commerce websites. Now, for example, if you take amazon.in, so amazon.in cannot wait for 6 months or 1 year, right? If you wait for 6 months or 1 year or 2 years to get completed the complete project, then no, the market can be captured by some other competitors. So that is the reason most of the companies, what they do, when they approach any company, they will ask them to uh, partially, at least partially deliver some of the project, not at least not the full project, but at least complete partially and give to us, so that we will deploy into the website. We can deploy into the server, so that at least my customers can buy some products. For example, Amazon having thousands of products in their website, but Amazon cannot wait to complete the all the complete website, right? You can ask the company that, do not develop all the 1,000 products, just develop give just 10 products you develop and give it to us. in 15 days, so that I can deploy, and that 10 products at least I can sell into the market. Then every 15 days, the developers, if they give 10 products, then within few months, Amazon can show multiple products in their website. So that
Yes.
means what? Every 15 days, these developers have to complete. Then only Amazon can benefit from it. If Amazon waits for a long time,
Mhm.
then Amazon will lose it. That is the reason now waterfall methodology will not work. So in the market, most of the companies follow agile methodology. Most of the companies follow agile methodology. In agile methodology, we have different terminology actually. For example, sprint is a terminology. Sprint means timeline. Sprint means timeline. Timeline to develop the project. One sprint normally includes 2 weeks. 2 weeks means if you include weekends as well, that means 15 days. But actually, it involves only 10 working days. Okay, 10 working days. So what happens is every sprint they will decide, the developers will discuss with the client, saying, asking like what 10 products, what 10 different products features you want to develop by us. Then the clients will inform that we want to you to deliver these 10 features for us. So features, you can call it as features, you can call it as a product, no problem. So they will say in sprint 1 what products you want to deliver. So in sprint 1, how many which what features to be delivered. So like that, we have around every 2.5 months, every sprint like that, 5 sprints will be there normally company, it's not a rule, but normally they will do like this for 5 sprints. They will do like this for 5 sprints, and then after that they will take a break. So still 5 sprints they will work continuously. Once a sprint is completed, immediately they start second sprint and third sprint and fourth sprint and fifth sprint. By this way, they can deliver a good number of features, so that the client can deploy them into the website, and consumers can use them. After 5 sprints are completed, normally these developers and the clients will sit together. They will connect online. If the clients are in US, they will connect to the online, and they will discuss like, no, it's all part of this agile methodology. They will discuss what went wrong, what went good. Okay, so what next in next coming 5 sprints, what to be delivered, what features to be delivered, everything they will discuss. They will plan accordingly after completing the 5 sprints. So they will take some 4 to 5 days time, or 3 to 4 days time. In this 3 4 days time, they will discuss all these things, and again the sprint 6 7 8 9 10 will start. So this way the development will be happening. But one problem you should understand in agile methodology. What is the problem? Problem is the administrators have to deploy the project in every 15 days. The administrator
Yep.
previously in waterfall methodology, they got enough time, so at the time they don't felt any stress. But now in agile methodology, administrators cannot perform, they cannot do deployment in every 15 days. Actually deployment will not happen only on 15th day, like that. Actually in between also, in the sprint contains 15 days. Out of these 15 days, the developers can ask the administrators to deploy the code at any time, on 7th day or 8th day, again on 15th day. So like that, the administrators have to support the developers.
Yeah.
So in this case, administrators cannot able to uh, continue. Maybe they do it for 1 or 2 sprints, but they cannot continue if they follow the same manual process. The manual process, what they do, suppose the code has to be deployed in 50 servers. Then administrators has to prepare 50 servers, and then they have to log into each 50 servers, and they have to deploy the code manually. If they continue doing the same way, then they cannot, the agile methodology definitely will fail. Even though developers able to complete the features, but their code is not installed in all the servers on time, because administrators following the manual methods. So by observing the situation, some companies like Red Hat, and actually not Red Hat, there is a company called Ansible company. This company is later acquired by Red Hat. So, and HashiCorp company. So such companies, what they did, they introduced some softwares, some we can say them as automation tools or softwares, which will do the same manual work, but with the help of a software. That means everything will be automated now onwards. That means if administrator taking some 1 day time to complete a task, then if you use the tools can complete the same task within minutes. Within minutes that same task can be completed. So these administrators slowly learned these softwares. Some softwares failed initially, and slowly now we have very good tools which we are learning in this in our course. So these tools are mature tools. Now using these tools, now these administrators are able to deploy the applications in on every 15 days. Not only 15 days, even on 7th day, 8th day, whenever developers ask them to deploy the code into servers, then administrators able to do it with the help of the tools. Now because these administrators know learn these tools and they are using these tools, the same administrators we call them as DevOps engineers. We call them as DevOps engineers. DevOps engineers are nothing but the people who do not do the administrative work manually, but they do the same work using some software tools.
Tools. Yeah.
Correct. So that way DevOps engineers role has come into picture. That way
Yeah.
DevOps role has to come into picture. But still we have administrators, still they are there, but where are they are in the data centers. So for example, if you take Infosys or TCS or any company, every company will have their own data centers. It's a big building. In that they will maintain all the servers. So in that administrators will be there. They will be laying out the LANs and various things, and they will be checking the servers which are crashed or which are not running properly. They will test those things in the data center. But DevOps engineers who are converted people, who converted from administration to DevOps engineers by learning these tools. So not only administrators, even non-IT people like developers like me, people like you are learning these tools. And now once you got the knowledge, then we can take a job using these tools. So now we are called as a DevOps engineers. The only task we have to do is that deploying the softwares into the servers and creating the servers. These this kind of tasks we will do.
Yeah.
So we have multiple different types of tools. We will try to understand what each tool will do.
Yep.
So here, before we going to learn each tool, here we have what is DevOps. Let's try to understand. DevOps is a set of practices that combines software development and IT operations team. So DevOps is not a tool actually. DevOps is a set of practices. Okay, but in these practices we use some tools. Okay, so using these tools now, DevOps engineers will not sit in the data center. Now DevOps engineers will sit along with the developers now. So
Mhm.
developers and DevOps engineers, they all sit at the same location, same place, same floor. Okay, they collaborate each other, and if the developers having any issue, they can discuss directly with the DevOps engineers, and DevOps engineers also can directly go to the desk of the developer, and they can discuss if they want any clarification from them.
Yep.
So
Yep.
where the multiple tools are connected to each other to perform the automation of all the activities. So as I told you, we have a lot of tools actually. So the tools which just now I've shown you, we have different like GitHub, Jenkins, many tools are there, right? So Terraform, Ansible, all these are tools. So these tools, if you use together and connected together to perform the automation of all the activities, right, we will see those. It aims to shorten the software development life cycle, so and provides continuous delivery with high software quality. DevOps is complementary with agile software development. Several DevOps aspects came from the agile way of working. It's a continuous development. That means every 15 days, if features are completed, and immediately development will start in next sprint again. So the development will be continuous actually. And also in each sprint, testing also will be done continuously, and continuous code integration will be done, and continuous deployment will be done by us as DevOps engineers, and continuous monitoring also be done.
Yep.
So the same thing what we discussed till now. If you go to waterfall methodology, design will be done, and then code will be done, and code normally will take long time, and then testing will be done, and then after that finally deployment. With agile, you see here, if you agile, if you use agile and you don't use DevOps tools, then what happens? Then you can design code and test, but you cannot deploy. Again, you can design code and test, but you cannot deploy. Deploy if happens at the end again, then no use of having agile methodology, no use of following agile methodology. So to be get success, then agile should follow, should happen agile with continuous deploy if happens, then agile methodology can be worked out. That means design, code, test, deployment, design, code, test, deployment. If this continuously you do this, then the client, whenever a code is deployed, then the client will get is 10 first 10 products. Again you deploy, the client will get next 10 products. Like that, the client will get every sprint he will get new features available for him to show in their website. So this way,
Yep.
agile with continuous deployment is necessary. But for continuous deployment, we require DevOps. We require DevOps. So why DevOps now? You might be understood by now. Or to overcome the drawbacks of
Yes.
traditional software development lifecycle, waterfall methodology is not a problem with waterfall methodology, but waterfall methodology is not suitable for the current scenario. Collaboration between development and operations team. So since the DevOps engineers sit along with the developers, there will be a good collaboration between the development team and as well as DevOps team. Automate the complete workflow. So everything will be automated by the DevOps engineers.
Yep.
So the
So
tool, yeah.
just a quick question, Madan. Like
Mhm.
I've heard about DevOps developer. So what does DevOps developer do?
Coming in, please, Tarun. What you said?
What does DevOps developer do?
DevOps developer. There is no DevOps developer actually. Only DevOps is separate. Developer, DevOps engineer is different, and DevOps and
Oh,
developer is different.
okay. So I just when I'm doing some research, I just came through like DevOps administrator, DevOps developer, DevOps engineer, DevOps architect, and like some kinds of roles. So just enthusiastic to know like what DevOps
Maybe
developer will do.
maybe in Kubernetes we can write extensions to Kubernetes actually. At the time, the if anybody DevOps engineer working on Kubernetes, if you know how to write code for extensioning the Kubernetes, then you should know the language Go language. So people who are already having some background development background, they can become as a DevOps engineer, so they can write code for Kubernetes. Maybe that in that sense maybe they're saying that, but that role is very rare actually. That role is very rare.
Okay.
Okay.
Yep.
So for that, maybe the key calling like that, maybe I'm just assuming like that. Maybe I'm not I may be wrong.
Okay. Okay, Madan.
Okay, but
Thank you.
yeah, no. So here on the left side we have developers, on the right side we have operations team. So as you know, these people will develop the code and create the applications. And operations team, this will prepare the infrastructure and maintain the infrastructure, and DevOps engineers come into picture to perform all the automation activities. They perform all the automation activities. If you take an example, for example, assume we got a Java project. So we got a Java project, then admins will do what they prepare the server setup. So for example, assume you got a project now. In the agile methodology, suppose a company they got a Amazon project, for example, and assume to complete the project, the company decided to have 10 teams. The company decided to have 10 teams. So every team working on one feature. So Amazon want 10 features in 15 days to be completed. So one team working on one feature, another team working on another feature. So in every team, normally there will be around six developers, two testing team, one lead and one scrum master. That is in agile method that normally the companies follow that way structure, they follow that way. So if there are 10 teams, then you can understand there are around 60 developers working all together. So when the 60 developers start working on the feature, when they start development, then in this 15 days time, what they do, once they complete the task, they will ask the DevOps engineer to deploy the code into the development servers. Okay.
Yep.
So their code has to be moved to a development server. See, one thing you should understand. See, developers, when they're developing the code, when they're programming, they will work on their local machine. They work on their local machine. On the left side, you see three machines are there. These are the local machines. These are the local machines. So these local machine, they write for example, if you take Java code, they will write the Java code, and they will uh, convert that Java code to binary format, and then they will execute the code. So you may be confused here. See, Java code is completely in the form of English. see, you take .NET or Python, everything is English, right? But our computer does not understand Java or .NET. So that code has to be converted to binary code.
Binary form.
Binary code. So that is the reason the developers who are working on the local machine, they use some tools. That they use some tools. Those tools will allow both writing the code, and also the tool will convert that code to a binary format, and the tool also execute or run that application whatever they have developed. So like that, 60 developers continuously they will develop the code, and every now and then they will test their code, they will run the code, and they'll see whether the code is working or not properly. So like that, they will spend some good amount of time in the sprint, and once on 8th day or 9th day, once they're satisfied with the development, then they will move their code to the development servers. Development server or development environment, we can say. Development environment or development server, both are same. What does it mean actually? So all the 60 developers code has to be moved to the development server. That means all their code has to be merged in one place, and the complete code has to be converted to binary file, and then that code should be executed. So by doing this, what happens? By doing this, what happens is that on local machines their code will be working fine, but once their code is moved and merged together, then they may see the problems. Why? Because some developer working on a file called a.b, a.c, some a file, and another developer also working on the same file, a file. Now unknowingly both worked on the same file, and they modified some code in that. And because of this situation, the one developer A's code may not, A's functional whatever he developed may be working on his local machine, but once it is run on the executed on the development server, his application may not be working, his task is not working, maybe his functionality whatever he developed is not working, maybe. Why? Because the other developer also did some same changes on the same file. Due to that, maybe is the first developer's code may be disturbed. Some changes has to be corrected. So by this, the both developers will sit together and they will discuss, and they will come with a solution. Once the solution is correct found, then again they will change the code, and again they will deploy the code into the move the code to the development server. And the development server, all their changes will be merged together. Again that code will be converted to binary format, and then it will be executed. And then once it is executed, and every developer will check whether the code is working properly or not. So normally in real time, the developer will not work on his local machine. He always initially work on his local machine. Once it is working fine, only then definitely they all have to move their code to the development server. Once the code is working fine in the development server, the code has to be moved to another environment called SIT environment, and another environment called SIT environment. What is SIT environment? SIT environment means system integration testing. System integration testing. So the developers will tell to the testing team saying that we have completed our code. Now code is available in this server SIT. You please test the code. So then the testing team will test the code. The testing team will have some test cases. Accordingly they will test the code, and if it is working fine, once they have mentioned that code is working as expected, then the code can be moved to another environment called pre-production environment. In this pre-production environment, a person from the company will connect to this server, and he will verify whether the product that features are working properly or not, those 10 features working properly or not, as expected they are working or not. Once it is working as expected, then the code can be moved finally to the production server. Production server is nothing but the servers where public can have access. That means amazon.in. I am saying when I type amazon.in, I could see the output. So how can I see it? I can see it because the amazon.in application is running in one of the production server. So because it is running in one of the production server, due to that reason I'm able to access it. So production server is nothing but your end users can able to access them. So we will move to production server only when it is confirmed that the development has done properly without any issues. Like that, regularly every sprint this will happen. Regularly this will happen. So if to elaborate more elaborately, if I explain, see, I will take one development server. For example, I'm talking about one development environment. If you see the next screen, still there is same screen, but this time we have 3 developers, right? But instead of 4 servers, we have one environment. You can think it as a development environment. This is a one development environment. Now in between we are seeing some tools. Now I'm trying to introduce some GitHub, some DevOps tools. One is GitHub, another is Jenkins, another is Maven. So what are these tools? See, when I told you that when the 60 developers complete the development, that code has to be moved to central location. At central location, nothing but they will move that code to a tool called GitHub. GitHub is a what do you call? It's a code repository. It's a code repository which stores the code. It's a central repository. It can store the code developed by all the developers. So the code, GitHub will store the code, and GitHub also maintains the versioning as well. That means who did what change at what time. So the GitHub can maintain history. If the project is going on for the last 3 years, then GitHub can maintain all the history for the 3 years. So GitHub can give you all the details. Suppose, for example, so and so month, so and so day, I want that file, who changed it at what time. So every detail you will get it using the GitHub software. So GitHub will provide you all the details. So it is both code repository tool as well as version controlling tool as well. So it have both names, version controlling tool and code repository tool. So once the code has been received, the latest code has been received to GitHub. So how it is received? The developers will move the code from the local machine to the central repository. That is the GitHub. So GitHub is a tool which handles the code. Now GitHub will immediately inform to another tool called Jenkins. What is Jenkins? Jenkins is called as a mediator tool or a CI/CD tool. CI/CD means continuous integration, continuous deployment tool. So Jenkins, or in short, we can say Jenkins is a mediator tool. Mediator means it's like a middleman. It will communicate with all other tools. So it will communicate with all other tools, and it will delegate the work. It will delegate the work. So now GitHub will inform to Jenkins saying that I have received latest code. Then Jenkins will immediately connect to GitHub, and it will pull the code from the GitHub, and that code will be given to another tool called Maven. It will give the code to the another tool called Maven. What is Maven here? See, as I told you, every developer will on his machine, he will develop the code, and I told you, yeah, he uses a tool. The tool will convert the Java code to binary code. I told you, right? The converting of Java code to binary code is done by Maven here. Maven here. So the Maven will convert the Java code to binary file. Once the Maven we call it as a build tool. So Maven tool understands how to convert a Java code, but Maven does not know how to convert a .NET code or C# code. So then for converting a binary C# code to binary format, then we use another tool called MS Build. So you don't worry about these tool names, but in short, you try to understand that GitHub having the raw code, the code, the Java code or C# code, any code, it cannot have binary code. Remember, a GitHub cannot have binary code. It can hold only the raw data in the format of text, images, no problem, but not the binary files. So GitHub informs to Jenkins, and Jenkins will pull the code from GitHub, and the Jenkins will give that code to Maven. For what? For what purpose? So that Maven can convert the Java code
Binary
to
form.
binary binary form. Then once it is done, Maven will inform to Jenkins saying that I have just now converted the Java code to binary file, and I also stored that binary file in certain location. Then Jenkins will go to that location and pick that binary file, and Jenkins will deploy that code into the development server, for example. Then the application will be started running here. Then immediately Jenkins will do what? It will inform to every developer, every tester, everyone, including your manager, everyone, through mails. So you have to configure that. We will see how we can configure it when we learn Jenkins. So Jenkins will inform to everyone that the application has been deployed in the so and so environment. Then if it is a development environment, then developers will immediately connect to the dev server, and they will test whether their functionality is working or not. If it is working fine, no problem. If it is not working, then again everything will continue. That they will communicate with developers, they will fix the issue, they will move the code to GitHub. GitHub will inform Jenkins. Jenkins will pull the code from GitHub, and Jenkins will give the code to Maven, and Maven will build it. And Jenkins will pull the binary file and deploy into the target machine. The target machine can be your dev environment, SIT environment. It could be anything. Any questions here, please, till now?
No, it's pretty clear.
It is clear.
So
It is clear, Madan.
it is clear, right? So you don't worry what these tools are doing at this moment. It's a simple demo, right? You just listen,
Yeah.
okay? Just listen. How much you can grasp, you can grasp it. no
Yes,
problem at
yes.
all. But if you have any questions, just ask me. I will explain you. I'm happy to explain you. Okay,
Yeah,
then
sure, Madan.
yeah, then let's take just enjoy the show. That's all. Okay, don't worry about this. If you're feeling some
Yeah,
difficult concept, don't worry at all. Okay, just try
yeah,
to understand if possible. And now take another scenario. For example, assume we have to install a requirement like install Java on 300 machines, and we have some 100 machines comes under development environment, and another 100 machines comes under SIT environment, and another 100 machines comes under production environment. So in real time, for example, if you take Amazon.in application, for example, so Amazon.in application, daily that application used with thousands of people, easily 50,000 to 1 lakh people will use it, right? So that is the reason in real time we will have multiple servers. Maybe multiple, why you may be getting doubt why we require multiple servers, right? So,
Mhm.
for example, if you go to a restaurant, and then somebody some server will come to you, and you will ask your what you will have. So once you mention the food items, then the person will go to the kitchen and he will inform the cook that we want to cook this item. Then the cook will
yep,
prepare it, and the server will again go back to the customer and he will serve the food. So this is fine, if there is one customer, one server is fine. But in Hyderabad, we have how the public here. So here in the restaurant, there one server is not sufficient. There could be lot of number of customers, there could be 50 60 customers at a time, and one server cannot handle them. If
yep,
if the restaurant and only having one server, then definitely the customer will not come back again, right? Because the waiting period will be more. Similarly similarly at Amazon.in website, if you take, that application will not be running in one single server. If you running the application in one single server, that means it is same like you having one server in the restaurant. That means
yeah.
daily
Got it. Yep.
50,000 1 lakh people coming to your website, and you serving all of them with one server, impossible, right? The server will be
Yes,
fully utilized, full RAM and CPU will be fully utilized, and it will be crashed. So that is the reason.
yes,
Similarly, the restaurants will have multiple servers. Similarly, in real time also, we will have multiple servers, thousands of servers actually, to be precise. Thousands of servers will be there. In all those servers, the same application will be running,
yep,
and these servers will serve uh, multiple peoples. So
yep,
similarly, so these servers, again, they are tested, they will be tested in hundreds of dev servers, hundreds of SIT servers, hundreds of production servers they will deploy. Anyway, so this Java has to be deployed in under these servers. Then if you go back some 20 years back, then how the administrators do without using the automation tools. They have to log into each and every machine, all the 300 machines they have to log in, and they will have to check whether Java already installed or not. If it is already installed, they have to uninstall it, because the version they may ask you to install maybe some version number 11, and the Java they found something version number 8, so they have to remove it. So like that, they have to check every machine. Okay, and in third point says that get the software from the shared folders. So in real time, we won't they will not company will not give access to the internet to download whatever software we want. Normally the software will be already downloaded and kept in a shared folder, so that whoever want it, they can they can copy that and they can install that software on their machines, right? So, and after that install the software, they have to reboot the servers. So all this manual work process of deployment in historical way takes a lot of time to complete the deployment on all the servers, right? So to avoid the situation, if you used a tool called Ansible automation tool, or a Ansible configuration management tool, so if you use this tool, the same task can be completed within minutes. The same task can be completed within minutes. Okay, so how the Ansible able to do? See, now introducing DevOps process, we will be including a tool called Ansible into the deployment process, which run playbooks of commands to perform the automated deployments on multiple servers with single click. So one thing you should understand here, I used a word called which run playbook of commands. Playbook means what? See, normally you do some paintings. Where you do normally we use MS Paint, Microsoft Paint, paint brush we use, we paint there, and we save them in the form of JPG or PNG or some other format, right? So, but you know what is JPG, what is PNG, you know, and what is PNG also you know, because we use it regularly. You also know what is Notepad, and what you also know what is Word, but you, Playbook we don't know. The people who working in Ansible tool, those they can easily understand what is Playbook is. It's simple. It's again a file. You talk, you say Word, Notepad, JPG, whatever you say, those are all files, right? Similarly, Playbook also is a file, but this file contains some different data. This file contains some instructions like what software to be installed. You are using Ansible to going to use Ansible tool, then Ansible tool will go through this playbook file. It will check the you will give the file name to this tool, and this tool will read the file contents. So whatever you mentioned in the inside of file, accordingly the Ansible tool will act. Suppose I want to install some Java, then in the playbook file you have to mention that in the form of instruction. So how you instruct, if you see on the right side, here in the right side, assume in the playbook we have only two commands for time being. Assume we have two commands. Normally we won't have two commands. We will have multiple lines. But as of now, try to understand we have only two commands. One is connect colon all. Another is m colon name equal to java hyphen 1.7.0 something and state equal to present. I'm saying. So Ansible understands that okay, I have to install Java version 7, and in where I have to install connect colon all. I'm saying that means Ansible understands that okay, I have to install in all the servers. I have to install in all the servers. Fine, but how the Ansible servers knows how can the Ansible server connect to a server? See, like every house has a house address. Similarly, every server will have IP address, right? So
Yep.
in another file, we call it as the inventory group file. In the inventory group file, we will give all the IP addresses. We'll give all the IP addresses. So normally we will be separate them with a heading. Suppose dev, we will give dev, under that we will mention all the IP address of those all 100 servers. These all 100 servers IP address will mention under dev and dev section. Similarly, under UAT section, we will mention remaining under IP address, and similarly under production heading, we will mention remaining production IP addresses. So if I said all, then Ansible will go through the inventory group and it will ignore the headings, and it will simply connect to each server using the IP address mentioned over there. So if there are 300 IP addresses, it will connect to each and every IP address, and it will deploy the Java file whatever mentioned in the playbook. Suppose if you mention instead of all, if you mention only dev, then Ansible will connect to the IP addresses which are under dev heading. So under dev heading, what are those 100 IP address? Only those under IP addresses it will connect. Ansible will connect, and it will deploy the Java code. So all this can be done within minutes. As shown above, Ansible deploys hundreds or thousands of servers at a time. So the time here is reduced to just 4 to 5 minutes instead of hours.
Mhm.
So in a macro level, I'm teaching in a macro level, but you try to understand what this tool can do. That's all.
Yes. Yep. So, how many commands do we usually have in Ansible? Like,
Actually, you should understand that uh, when you go to Ansible website, you will have full documentation. You will have all the templates over there. You no need to learn anything. You no need to understand how to do scripting. We can simply copy the templates over there, and we have to paste on a local machine, and you can modify it some here and there, and you can test it, and you can use it in production.
yeah,
For every activity, we have templates.
yeah.
Okay. Right, and moreover, this Ansible also serves another problem. What is another problem it solves? For example, you went to a company, you joined newly, and and you don't know, already there are some hundreds of servers running on, and you don't know on each server what softwares are installed. Tomorrow if somebody asks you to install some other software, okay, but no, don't know what software is already installed over there, and for that, you can check the playbook. When you go to the playbook, in the playbook every instruction, every software whatever installed before, everything will be mentioned over there. So by seeing that, you will understand okay, in this connect it is connected to dev environment, and it has installed this software. By seeing this playbook file, we will understand what softwares are installed, and assume when there is no Ansible, for example, then whoever installed the software manually, they will maintain the information in their local machine in a notepad. And when you join in that company, that person will give you KT. Of course, at the time, if he informs you about that information, what softwares are installed, then fine. But if he does not inform that information, then problem, then that will be a
Yeah.
problem. But when you are using Ansible, then you no need to worry, because somebody already using Ansible, then there are Ansible files over there. In that files, all the details are present. You can use them
Yes.
accordingly.
Yeah.
Now you see, we have attached our Ansible to our Jenkins tool. Now we are attached to our Ansible to our Jenkins. As I told you, Jenkins is just a mediator tool. It's just a mediator tool. It cannot deploy the binary files into multiple servers. Actually, it has to delegate that work to Ansible server. Ansible server in turn, it knows very well how to deploy the software into multiple servers. It will take that job. So this way, Ansible software has to be installed on Jenkins. We call it as a plugin. So whenever Jenkins want to communicate with Ansible, then you have to install a plugin or a software, so on Jenkins tool, so that Jenkins can communicate with Ansible. So like that, we will slowly go on, attach different tools to Jenkins, and Jenkins will manage all these tools. It will communicate with all these tools, and it will uh, do the job complete. It will see that job is completed.
Yeah. So, is there only one, only one tool like Maven, which only convert the code to binary form, or is there any other tool?
Okay, I told you actually. So for .NET C# code, we will have MS Build. We will have MS Build. For example, if you are using C language or C++, we have another tool called Make. Make is a tool. Like that, we have multiple tools for multiple languages. So in this example, we have used Make Maven, because we are talking about Java code. So it knows how to
Java.
convert a Java
Okay.
code, right? For that
Yeah.
purpose. So when we are learning this Jenkins, no, at the time, we'll come to
Yeah.
understand what are different types of build tools are available like Maven, what are the other tools are also available. That at the time we will discuss thoroughly.
Yeah.
Now coming to Terraform. Now Terraform is a infrastructure management tool. Terraform is a infrastructure management tool. See, you try to understand, some 20-25 years back, whenever a client comes to any company, Infosys company, so they will talk everything. Finally, Infosys says that to come we require around 50 servers to purchase. So the client will agree, for that, yeah, yeah, in the budget they will include that cost as well. So the company Infosys will buy the 50 servers. At the time, there is no cloud. Okay. Now once the Infosys developed the code and everything is deployment is done, then after 5 or 6 years, those servers which they have purchased, those are now uh, obsolete. They cannot be used. They cannot be used for installing latest softwares. They can be used only with old softwares. For example, if you have a laptop and 10 years back old laptop, we can install Windows 10, but now in the same laptop we cannot install Windows 11, because hardware doesn't support. Similarly, at the time, the servers they purchased are useless after 5 6 years. But now, the same client comes to Infosys, and this time the client will not agree for the purchasing of physical servers. The client will say, of course, Infosys itself say that. So they both will decide to create servers on the cloud. What does it mean? That mean that Amazon cloud or Azure cloud or GCP cloud, what are the cloud providers do? They actually they have lot of huge infrastructure available with them, and in complete world, in the world, in every big in very good in big cities, they have their own infrastructure in the form of data centers. Like Infosys having their own data center, these cloud providers also having their own data centers. So in their data centers, they have very high end infrastructure. So these cloud providers do what? They will give this infrastructure on rent. So the Infosys company or the client can take this infrastructure on rent basis. So the project, they can use this servers, high-end servers and they can use it for 6 months or 1 year. Once the project is completed, then they can terminate these instances. They can revoke access to the servers. And what these companies have to do, they have to pay only monthly bills. That's all. monthly bills, whatever instances they have used, whatever servers they have used, whatever infrastructure they have used, for that they have to pay the bills, that's all. And they no need to purchase any physical servers, right? So why I am teaching that is now, why? Because Terraform is a infrastructure tool, infrastructure management tool. That means when suppose the client wants to create 50 servers on the cloud, then Infosys company will ask the DevOps engineers to create 50 servers on the cloud. Then as a DevOps engineers, we have to write a script. As I told you, for Ansible in the web, in their website they have already ready-made templates. Similarly, Terraform also they have on their website they have their own templates. You can use the templates, no problem. All ready-made templates are available already there. You just have to modify here and there, that's all. So once you modify the template, in this template you will mention how many servers required. and and Terraform is a brilliant software, and high demanded software. Why? Because this Terraform can work with any cloud, any type of cloud. It can work with Azure, GCP or AWS. Okay, now in this Terraform we can mention how many servers you want. 50 servers, okay, Terraform will immediately connect to the cloud. In this file, assume in the sample.tf file, assume I have mentioned the cloud name as AWS, then it will connect to the AWS. And if I mention 2 servers to be created, then Terraform will create 2 servers here. At the same time, Terraform also writes IP address details of these 2 servers in a file called terraform.tf state, in a file called terraform.tf state. So IP addresses are updated in this file. Why? Why? Because tomorrow Ansible has to install some softwares accordingly mentioned in the playbook. Whatever mentioned in the playbook, those softwares has to be installed. But for that, Ansible has to know the IP address of those instances, right? So previously we discussed here, we have what? Inventory group files. Inventory group files are there, but now it can use both inventory group files as well as it can use Terraform TF state file as well. In this Terraform.tf state file, the Terraform has updated the newly created instances IP addresses. Now Ansible can accordingly go through that IP address, and it can connect to the instance, and it can install the softwares mentioned in the playbooks. So that means everything happens parallelly. So till now I have not answered your question, what is EC2 instance? I will answer it in a moment. So in this picture, do you have any questions, please?
No.
No, 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 no.
Thank you. So if you are exhausted, let me know, please.
No, no, we are all good.
Okay. Okay. Then I'm coming to your question. You said what is EC2. So let's try to understand what is EC2. So before we understand EC2, here the concept we are going to learn is Docker containerization. What is Docker, and why it is called as a containerization tool? That we try to understand. But before we try to understand what is Docker, we should understand what is virtual machine. We should understand what is virtual machine. See, again, long back, some 20-25 years back, at the time, a lot of companies used to deploy only one application in one server. Only one application in one server. Why only one application in one server? Because assume if they install two Java applications in the same machine at the time, so one Java application may be using one version, and another application may be using another version. So normally versions here, see, when you develop a code, Java application code, developing the code is like constructing a building. Developing the code is like a constructing a building. So you can't directly build the house. So before building the house, you have to lay out the pillars. So pillars you have to build, create, and after that, with on that support, you have to construct the building, right? Similarly, developers when they develop the code, they are nothing but they're constructing the building. But the code has to be, when they deploy the code into the server, at the time before the application that Java code is deployed, before that they have to deploy another software called Java runtime. They call it as a Java runtime. If it is a Java application, we have to install Java runtime. If you are developed in .NET, then you have to install .NET runtime. Like that, for every language we have a runtime. So this runtime is like a pillars. So why I've told you now that, because I'm telling you that in olden days, one physical machine used to have only we used to deploy only one Java application. But when you deploy two Java applications, then these two Java applications will have their own runtime softwares, as I just now informed, pillars kind of. So these runtimes also having some version numbers. One can have version number 8, another can have version number 11, and you install two applications in the same machine, for example, at that time. So one application which has to use version number 11, but it will confuse because it is seeing both versions now in the same machine. One is 8 and one is 11. So it is confused as, and it may, if it uses if it uses 8, then it will collapse. And another application, another Java application, it has to use runtime version 8, but if it uses 11, then it also crashes. So due to that reason, at the time, they used to deploy only one application in one server. The problem is solved, but another problem is that this one application is not able to utilize the underneath hardware, the infrastructure, in hardware infrastructure. The application, one single application, has not able to use properly, because the RAM size is some assume 4 GB, then the application requires only 1 GB. And similarly, the CPU assume having some 2 core or 3 core, then the Java application uh, is not consuming the full core actually. And similarly, hard disk also, if hard disk is 1 tera or 500 MB, sorry, 500 GB, then the application requires only some 5 GB. So there is a huge wastage if they deploy only one application. So some companies observed the situation. They observed the situation. Then what they did, they developed a software. Like similarly, in the beginning of the demo, I said that by seeing the problems of administrators, they developed some tools. I said similarly here also they observed some problem, that is, say, what is that? One application is not able to consume the hardware properly. It is wasting, right? So for that reason, some companies developed a software called hypervisor. If you see this picture, it is a hypervisor. Hypervisor is a software. What it will do, it will actually it will do partitions. It will do logical partitions on the physical machine. It will do logical partitions on the physical machine. That means, suppose the company, now what they do, they will buy a high-end physical machine. High-end physical machine means some, they will buy some 64 core CPU, some 512 GB RAM, and some 1000 terabytes of hard disk. That much huge uh, configured hardware they will buy, and in a single, and they will configure in the same physical machine, and they will install on top of, they will install OS, some OS that could be Linux or Windows. On top of it, they will install hypervisor. Hypervisor do what? The Java, that this software is what it do, it simply it do that, it will do the partitions on the physical machine. Like for example, how many partitions it will do? For example, first of all, why partitions are required, we will understand in a moment. But how many partitions it will do? See, for example, if you take an apple, and if I ask you to cut it into 40 pieces, you can easily cut it into 40 pieces, no problem. But the each slice is very thin, and we cannot um, uh, we cannot, what do you call, enjoy the taste, because it's very thin slice. But if I ask you to make only four bites, four pieces, then whoever having it, they will enjoy the taste of it, right? So similarly, your hypervisor also, uh, basing on the size of your infrastructure, it will do proper partitions. It won't do, suppose only 20 partitions are good enough, then it will do only 20 partitions. If it can make even 200 partitions, but it's not usable, it cannot be usable. So 20 partitions or 10 partitions, accordingly, basing on infrastructure, it can make the partitions. Once these partitions are done, then what happens? These partitions we call as logical partitions, and in each partition, now you can deploy your Java application. In another partition, you can deploy your another Java application. Like that, you can deploy different applications. Now because they are running in their own logical partition, and they will have their own OS, they can have their own OS. On top of it, they can have their own runtime environment. The runtime environment software version 8 or version 11, whatever it can be. And another partition also can have their own guest OS. It can also have their own, what do you call, own runtime environment, could be 11 or some other. Now onwards, they won't disturb each other. They will use their own runtime environment. This application B will use its own runtime environment. Like similarly, another partition will use its own partition. It will use its own runtime environment. This way, one application will not crash another application. If it crashes due to some other reason, only this application will be crashed. But because of this, other application will not be crashed. But when you go to 25 years back, if one application crashed, the remaining also used to be crashed. So this virtual part, because of hypervisor, now we are able to do multiple partitions, and because of that we are able to deploy multiple applications, projects, and because of that all these applications are able to share the same infrastructure. So because of that, the infrastructure was not wasted. Easily 80 to 85% of infrastructure was properly utilized by all these applications. So whenever application A want to store some file in the hard disk, then the application A will request to guest OS, and guest OS will inform to hypervisor, and hypervisor it will inform to host OS will inform to infrastructure, and infrastructure will arrange the required space for storing that file. So this application, Java applications, thinks that it having its own infrastructure, but no, it does not have its own infrastructure. The infrastructure has been virtualized. The infrastructure has been virtualized. So every application thinks that they're having their own infrastructure, but no. So each partition we call it as a virtual machine. Each partition is called as a virtual machine. So logical partition or virtual machine both are same, but normally we say it as virtual machine. Now in real time, whenever you are working on any cloud provider, with any cloud provider, is it where you are working with your Amazon cloud or Azure cloud or GCP cloud. So what happens, internally, suppose you want one server, then that cloud provider will give you one virtual machine. You say, if it is Amazon cloud, you will say this part virtual machine as EC2. You will say it as a EC2. So EC2 is nothing but a virtual machine, one partition. You are using, you will be given one partition. One partition is given to you, then you can deploy your OS, you can deploy your application, whatever you want, you can deploy in it. So the cloud providers normally they will have thousands of physical machines like this in their data center with very high-end infrastructure, and all having lot of partitions. So tomorrow if you want 50 servers, then actually you are getting 50 partitions. You are getting actually 50 partitions, and the cloud says it as EC2 instance. So virtual machine or EC2 instance, both are same. So these partitions, they think themselves as a separate physical machine, but actually they are not. But it works like a physical machine only. But these are partitions prepared made by the hypervisor tool. So now to answer your question, EC2 instance is nothing but a virtual machine, and virtual machine is nothing but a partition on the physical on a physical machine. Any questions, please?
Nothing more.
No.
It is clear.
Okay. So give me 10 more minutes. I will finish it off.
Yep.
Just 10 more minutes, please. Now, yeah, thank you. Now the question is here. See, every part, assume for time being, assume we have 10 partitions. We have 10 partitions. Then assume for time being, guest to OS is Windows operating system. And Windows operating system normally when you install first time it will take 18 GB space, and once updates are happened, then it goes to easily 23 to 25 GB. So then here we have 10 partitions assume, and in each partition assume for some time all partitions having same Windows operating system, and that means every Windows operating system consuming around 25 GB space in each partition. 10 partitions means 250 GB is going for only the operating system. Now the real application, Java application, normally the application itself takes some space. How much? Mostly 850 GB, 850 MB or 1.5 GB space. So in short, all the 10 applications, if you put together, the applications just require around 15 GB to 20 GB space. That's enough for them. But the operating system itself taking around 250 GB RAM. Sorry, 250 GB space they are occupying. So this is one of the drawback. They are consuming more space. The operating system are using more space. Now again, some companies noticed this issue, and what they did, they created another software. They call it as Docker. They call it as Docker. Now this time, what Docker has done is, they previously the hypervisor did what it has virtualized the infrastructure. That means each application believed that they have their own infrastructure. Now Docker did what? It has virtualized the OS itself, the guest OS itself. It has virtualized. Now every application thinks that they're having their own OS, but they don't have now. The Docker software, software did what? It completely removed the guest OS layer. Now because it has removed the guest OS layer, what happened now? Now whenever application A wants to store some file, then the request goes to the Docker engine. Docker engine is a part of the Docker software. The Docker engine do what? It will take the request from the application, and then the request will be forwarded to the host OS, and host will forward the request to the infrastructure. Simple. So this way, complete guest OS has been removed here. Now this each application, here we saying that as virtual machine, but here we won't say virtual machine. We say them as containers. We say them as containers. So in Docker world, we use a word called containers. So in these containers, we will have only the application and application related binary files and library files. So this becomes a container. Now, because of this possibility, that now OS is removed now, that means around 250 GB has been saved now. Now because of this, the company is now able to deploy multiple containers. Remember the word I'm using, containers. So the containers contains what? Same applications. Virtual machines contains what? Along with the application, it contains guest OS. But here only the
OS.
application will be there. Right now, because of this reason, a lot of space has been saved because of virtualizing the guest OS. Now the company is now able to deploy, instead of 10 applications, now they can easily deploy 50 to 60 applications on the same machine. They can deploy 50 to 60 machines, applications on the same machines. That means 50 to 60 containers they can deploy on the same machine, because 250 GB has been saved here in this example, right? But because we are able to deploy 50 to 60 application containers, there is another problem arised now. There is another problem arised. What is that another problem?
Load
In
balance.
real time, we will not only that, the real problem is that in real time, there won't be single physical machine. There will be multiple physical machines. There will be around 20-30 physical machines, and on each physical machine there could be easily 50-60 applications. There could be 50-60 applications. And don't think that all these 50-60 applications are different. They actually, as I told you, example I given, Amazon.in, the same Amazon application running in thousands of servers. I told you, right? A copy,
Yep.
same servers are running in, same application running in multiple servers. Similarly, even though these 50 servers having only 4 unique applications running, and each application in running in 10 containers, same copies are running in 10 containers, like that. Okay, so here the real problem is that if you have 20 to 30 servers, physical servers like this, and on top of it, each physical server we have 50 containers, then if you take 20 servers itself, 20 into 40, 50 means around 1000. You have 1000 containers running, right? 1000 containers are running, and these containers sometimes they crash also. They also crash sometimes for some reason. They also crash for some reason. Then how can
Hmm.
we manage them? As a DevOps engineer, we cannot watch these many thousands of containers. We can't manage them. We can't watch them which has been crashed. If it is crashed, then immediately we have to replace with a new one. We have to remove it and we have to replace with a new one. So these things we have to do continuously. Imagine, cannot, it is not possible. It is not possible. Okay. So to solve this issue, to solve this issue, before understanding the how it is solved, these are the comparison between the virtual machines and the Docker. So virtual machines are
So
heavyweight and Docker. Yes,
yeah,
yes, please.
sorry, Madan. So after creating like in infrastructure as code, we create virtual machines. So after the virtual machines process, the next thing is like Dockers, right?
No,
Yes.
actually, it's again depends on the company. If the company they don't want to use Docker and Kubernetes, they can deal with virtual machines only. If the company wants to go with the Kubernetes and Docker, then we have to work on Dockers only, like that.
Okay.
It depends again.
Yes.
It depends
Yep.
on the requirement.
So they don't use virtual machines if they use Dockers and
You
Kubernetes.
are right. They yes, you are right. They still use virtual machines, but in that virtual machines they use they install Docker and in that they use containers.
Yeah. Yeah. Gotcha.
Okay. Still for still if to install this we require virtual machines again,
Oh, okay. Yeah.
right? Now virtual machines are heavyweight and containers are lightweight and limited performance and Dockers are native performance. Each virtual machine runs in its own OS, whereas Docker runs all containers share the same host OS. Hardware level virtualization, it is OS level virtualization. Startup time in minutes, startup time in milliseconds. Allocates required memory, here requires less memory space. Fully isolated and hence more secure. Here process level isolation, possibly less secure. And now the problem, how it can be solved? Thousands of containers are running. Then how can it be solved? We cannot watch them. Which container has been crashed? This we cannot watch them. So for that purpose, we have to learn another tool called Kubernetes. Kubernetes is a tool. We call it as an orchestration tool. So the job of this tool is that maintaining this all these containers, so no need to worry. So Kubernetes will handle all these containers. It will automatically verify if any container is not running or it is crashed, then automatically it will remove it and it will replace it with a new container. So
Yeah.
everything Kubernetes will take care.
So, sorry, Madan. What is the exact meaning for the orchestration?
Orchestration
Like
is simply right. See, in an auditorium, in a musical auditorium, a guy with a holding with a sting is swinging the stick in the hair. He will maintain all the artists, right? All the artists playing, they're using different types of uh, uh, playing tools, right? He
Yep.
will
Mhm.
control them with the stick, right? So
Yep.
there, to them we say orchestration, right? So the single guy
Yep.
controlling all these different artists, right? So exactly
Yes.
how the artists play accordingly with the swing of the stick, I don't know, but he is controlling them. So accordingly they
Yes.
play the instruments accordingly, right?
Yep.
Similarly
Hmm.
here Kubernetes, we can think it as a orchestrator who is controlling all the players, like that. It is our Kubernetes controlling all these containers,
The containers. Yes. Yes.
all
Copy.
the containers. Yep, yep. And the artists playing different instruments. Similarly here the artists are nothing but our containers. They are having their own applications running, different applications they are running, like players artists having different instruments, these containers have different applications. That is a
Yep.
something, something different actually.
Yep.
Okay, so just an higher level, just try to understand Kubernetes is a tool which simply handles these containers. Okay,
Yes.
so even here also we no need to worry how to watch them. So you know to worry. And next comes
Yep.
our final tool, that is Prometheus and Grafana. So monitoring Kubernetes with Prometheus and Grafana. So here one thing you should understand, of course Kubernetes can create a new instance if instance as if a sorry, it will create a container, recreate a container if the container crashes, that is fine. But if again and again some containers are crashing, if again and again some containers are crashing, then Prometheus is a monitoring tool. It will log that information in a text format. It will log that information which containers are containing are what you call crashing again and again.
Crashing.
That
Yeah.
information will be lagged in the logged in a text format. So as a DevOps engineers, we will go through the actually when we install the Prometheus will take care all of these things. But as a DevOps engineer, still we have to do one step, that is we have to go through the log file and we have to understand, we have to read the logs text and we have to understand which container, which containers failing multiple times. Then
Yep.
the DevOps engineer should understand what application was running in those containers, and if the application they know, then they will inform the respective developers that your application is crashing multiple times. Please have a look into it. Though this is crashing, and this is the information crash details. So the developers will fix it, and again they will redeploy it.
Yep.
Here the Prometheus job is logging that information, and but reading that logs in a text format is difficult for some time if you have more long data. For that reason, we use another tool called Grafana. Grafana it takes this log file as input, and it will show the same content in a graphical way, in a chart way, in a bar chart way, in different visual form. It will show the same data, so that as a DevOps engineer, by seeing the graphical interface, we can easily understand what was the problem, which application having the problem. Those we can easily understand without going through the text by line in the log files. So that for that
Yep.
purpose we use Grafana.
Yep.
So
So
finally, yes, yes,
yeah.
please.
So what about Nagios? Are the same like Nagios and the
Yes,
Prometheus are the same?
Nagios, see, both are same. You can use Nagios.
Both are
Some
same.
companies still use Nagios. Some use Prometheus as well. No problem.
Yeah. Thank
Like here we have in the, like here in this year we have, for example, here number 7 JFrog. We have JFrog is a tool which stores the binary files, or we can say artifacts. So when the Maven file converted the Java file into binary file, that files will be stored in the JFrog tool. Actually, in the it stores the binary files, like GitHub stores the raw code, and Java stores the JFrog stores the binary files. So instead of JFrog, some companies uses Nexus also. Nexus is a tool that also used for the same purpose. Nexus or JFrog or Nagios or Prometheus. We have some tools. Okay, we have some tools, but if you go through this, if you know these tools, then you can learn those as well.
Yep.
You can easily understand those as well. So
Yep.
finally, if you put all these tools together, we call them as a DevOps delivery pipeline. And you see here on the left side, we have developers developing the code, they're pushing the code to the GitHub, and Jenkins will pull that code and push it, give it to Maven, and Maven will build it. And a testing phase will be there, testing will be done, and then continuous deployment will be done. And you know what is Ansible is for, and you know what is Terraform for, and you also know what is Docker and Kubernetes for. And finally,
Yep.
we have continuous monitoring tools like Prometheus and Grafana. So these
Yep.
two, all these tools we learn in our course.
Yep. Right.
Hopefully, maybe you already know some knowledge, but maybe I believe something I have also added some knowledge today
No, no, you just added
by
much
listening.
more like this. Yeah,
Yes, yes.
we can just learn by looking like looking into Udemy or LinkedIn, but we just looking for the live experience, and this is a great session. Like we can the explaining you're giving to us, it's like more easy way to understand. You know, we
Thank
can
you,
understand very
thank you,
easily.
thank you,
Like
Tarun.
yeah, for sure. If I have any of my friends, I'll recommend you for sure.
Thank you, Tarun. Thank you, Tarun. Thank you, Tarun.
Yeah.
Yes, Madam. Thank you.
So yeah, so thanks for giving your time, and sorry for taking the session for this long. I'm sorry.
No, no, no,
So
you're all right, Madan.
once again, yeah, once again, thanks for your time, and please have a good day. And you decide
Thank you,
properly.
Madan.
Don't worry. You have to
Yep.
learn anyway. You have to learn any course. End of the day, you have
Yeah.
to
Hmm.
put efforts. That is important.
Yes.
Yes,
Yeah,
yes.
Madan.
You choose. Yeah, yeah, right.
Yeah, we just
Okay then.
had
Take care. Yes, please.
yeah.
Yes, please.
Yeah, Madan, like as you know, we are working from 9 to 5 job in the morning. So we just asked the guy for the afternoon sessions, like you from 2 to 3, like whenever it's possible around 2 to 3 in the afternoon session for you, and he said okay. Is that okay for you in the afternoon sessions?
Yes, yes. No problem. No problem.
Yeah, thank you, Madan. Thank
Thank you.
you for
Thank you for
that.
that, Madan.
Thank you, Sandeep.
So
Thank you,
we can
Tarun.
start as soon as
Uh, uh,
possible.
Yeah,
yes, 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 yes. No problem.
So
Definitely, definitely.
and
we'll discuss
once
that
again,
and we'll let
it
you
was
know
a
in the
great
call.
session.
Thank you for that, Madan.
Thank you. You made my day. Thank you very much, Tarun. Thank you very much.
You made you made our day, Madan. You know, like you just gave like how everything works. We just have that like basic idea, but you know like can't say in words. Thank you, Madan,
Yeah,
and see you
yeah,
soon,
yeah.
hopefully.
Thank you. Thank you. Thank
Bye
you.
bye.
Thank you very
Bye
much.
bye. Have a
Bye
Bye,
great
bye.
Madan.
night,
Bye
you.
bye. Take care. Have a good
Bye.
day. Have a good day. Thank you. Thank you. Bye.